Hello guys, this is Sanjay. So I hope you're all doing great. So essentially we covered ketoenol tautomerism and acidity of alpha hydrogen in the first lecture, and we proceeded to alpha halogenation and haloform reaction towards the second lecture, and HVZ, which is the Helbola-Zielinski reaction, and the introduction to self-aldol condensation in the third lecture. And in the last lecture we have covered the reactivity of aldehyde, which is ketone, which is more reactive. Aldehyde is more reactive than ketone, right? Because of the steric and electronic factors which we have covered. If you did not see the videos previously, please go and check it out. So this is cross-aldol condensation also we covered. Now we will take cyclisation, right? So lots lot of teachers cover this topic within the questions session itself, but I will take it as a topic. So we take example. So we take this compound. This is what 1, 2, 3, 4, 5, 6, 7, right? Both are ketone and aldehyde is present in the same compound. So because aldehyde is more reactive, the aldehyde will undergo an attack. Okay, so this bond shifts towards here with an attack of a negative charge over here, right? This cannot this alpha how the attacks take place. We perform the reaction over the same OH minus only. You can say that the aldehyde the alpha carbon forms enolate ion and can attack another molecule of the same kind, but that cannot happen, the least chance of happening, because you see how big the molecule is. The attack is it's not favored in any ways. Okay, so this cannot happen. What will happen instead is this is also known as intramolecular aldol condensation. You know what is intra? Like intra-school competitions, a competition within the school, within the members of the school. Similarly, within the members of the chain, the reaction takes place. What will happen? Essentially, the same thing happens. So, negative charge, the alpha hydrogen is abstracted. Um, Possibility 1, it can be abstracted. Over here, possibility 1, or possibility 2 is you can get over here, right? So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this negative charge comes and attacks this position. What will happen? If this carbon comes and attacks this carbon, the cycle is formed. Okay, can you visualize? Cycle means a ring is formed. Here 1, 2, 3, 4, 5, 6, 7. 7-membered ring is formed. Okay, 7-membered ring are generally not stable because of the Weierstrain theory. I'll say what is it? 3, 4, 5, 6, 7. And here a 5-membered ring is formed. If this third carbon attacks 7th carbon, so whichever carbon attacks that carbon, within that all the carbons goes into the chain. The ring. So 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Okay. Now, first we'll come to we'll understand why 5-membered ring is this possibility is favored. Okay, this is not favored because 5-membered ring are more stable than 7-membered ring due to Bayes angle strain theory. For example, if you take this one, okay, what is this? Butane, cyclobutane, right? So if you take carbon of this, it's actually what sp3 hybridized, right? 2 hydrogens stay like this. So sp3 hybridized a tetrahedral molecule, right? So the angle is 109.28 degrees. We from the VSAPR theory and all, we come to the conclusion that tetrahedral carbon should have an angle of 101.2 degrees. But due to the formation of ring, the angle deviates by what? This formula, right? Okay, half into this, 109.28 degrees minus the angle due to the shape. Do you know, you understand what is this? Here the shape is what? A square, right? Essentially. Squares will have an angle of what? 360 degree by 4, right? 90 degrees. So 90 degrees. Yeah, all the corners have 90 degrees. So this angle here, in this case, it will be half into 109.28 minus 90 degrees. So this comes out to be around, 9.64. This much angle it gets deviated. So according to this, if you calculate which deviates, very less, okay, so that will be more stable. If you see here, when we calculate the same for using the same formula for cyclopentane, okay, you know it will come around half into 109.28 degrees minus, the according to the geometry, the angle will be around some 108 degrees. So you realize 109 degrees minus 108 point degrees, it will be very less number, and when we divide it by 2, it will be so less. So it is almost very very stable. So the angle strain is very less in cyclopentane. So we would think that it should be more stable, but the fact is cyclohexane, is more stable. Why? In general organic chemistry, you should have read about the conformers of cyclohexane, right? Due to those chair and boat conformers, they exist. They do not exist in flat structure, right? So, due to those facts, cyclohexane will be more stable. When you compare five membered and seven membered ring, five membered is more stable, and exceptionally cyclohexane is more stable. So we'll continue this reaction. So this is not stable, okay, not stable. So what will happen, this three membered ring contain, the third carbon contains a ketone group, C ketone group with a methyl over here, okay, and the seventh group undergoes this attack, okay, so this will be O minus. So now what will happen, you will attack with H2O to form this one, OH, and again heat it to form the same alpha beta unsaturated compound, okay. It will be like this. This is the compound for product. So we'll take one more example. First, you should see always the reactivity of aldehydes and the ketones, which will react and which will undergo attack, and then you should see the ring size that is formed. So if you take this one, so okay, now this is another example. So now here, if you see 1, 2, 3, 4, 6 membered chain. So any there exists symmetry because this is alpha hydrogen is forms this negative charge here, and for this it forms negative charge here. If it undergoes this attack here, both are aldehydes, so it will undergo equal attack. So if it undergoes the 6 carbon, if attacks here, 1, 2, 3, 4, 5, 6 membered ring form. And if this carbon attack over here, 1, 2, 3, 4, 5, 6, again 6 membered ring form. So it will be so easy. So write 1, 2, 3, 4, 5, 6. Second carbon attacks sixth carbon. Oh, sorry. 1, 2, 3, 4, 5, 6, 7 membered ring. But this second carbon attacks the seventh carbon. So 1, 2, 3, 4, 5, 6. So 6 membered ring forms. Okay. Second carbon attacks the seventh carbon. So we'll essentially take 2, 3, 4, 5, 6, 7. Understand, right? And second carbon will have a molecule of aldehyde. See, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. It's a 6 member ring only, right? So this 2 member second carbon will have an aldehyde group attached to it. So the seventh carbon will have O minus, and again the same dash. So this will happen OH over here. You heat it to form alpha beta unsaturated compound. So simple, right? So this is about cyclisation of aldol reaction. It's also known as intramolecular aldol condensation. See, the molecule inside the molecule only the attack is taking place, right? So it is known as intramolecular aldol condensation. So now we will see some one or two reactions based on the similarity of aldol condensation. Take one more example. So it's BH. So aldehyde always goes attack than ketone, right? So this has no hydrogen. You understand why? Because it will be kind of benzene here. So 1, 1 and 2 here. So where is the hydrogen? So no alpha hydrogen. So negative charge only forms over here. 1. So we'll number this 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. Okay. So this comes an attack over here. So what it will form? 1, 2, 3, 5-member ring. Okay. So I have a 5-member ring with 5, 4, 3, 2, 1. So 1 will have this OH over here, and this hydrogen will be in previous page. Oh wait, sorry. Yeah, correct only. So this hydrogen over here. So this fifth one has negative charge, attacks this carbon. It goes here. Okay, fine. So then now the sixth position, which is connected to this one, so it will remain as such. So it will be pH. So when you heat it, it will come like, it will be like this one. Okay. Take one more example. One, two, three, 4, 5, 6, 7, 8, 9. Do you realize over here symmetry exists, right? See, can you compare? Symmetry exists. So if alpha hydrogen forms over here or here, it is same. And if alpha, sorry, I'm saying alpha. So at this alpha position, if negative charge forms, and at this position if it forms, both are same. And similarly at this position and this position, both are same. If it forms here, it should attack this one. Okay, so 1, 2, 3, 4, 5, 6, 7, 8-member ring. So and similarly here, if a negative charge forms, it should attack over here. 1, 2, 3, 4, 5, 6, 7, 8. So let's wait for some time. So if negative charge forms over here, it should attack this one. So 1, 2, 3, 4, 5, 6-member ring is more stable. Similarly, if the negative charge forms over here, it will attack this carbon. So 1, 2, 3, 4, 5, 6. So we essentially form 6-member ring. We'll take anything because symmetry exists, right? We'll take this one. So 3, 4, 5, 6, 7, 8. So this third position forms negative charge over here and attacks this one. So it will polarize like this. So 8th position should have OH and a methyl group to it. Okay. So and the third position which attack where attack happens, it have this one, right? This second carbon, first carbon. So if you heat it, mind my drawing, it's so bad. But you know what, cyane? I'm a biology student. So it will be C double bond O CH3. This is a product. So similarly, we can take one more example. So if you wish. So this is another. So here 1, 2, 3, 4, 5, 6, 7, 8. This is ketone part. This is aldehyde part. So aldehyde part will undergo attack. Negative charge it forms over, if it forms over here 1, 2, 3, 4, 5, 6, 7, 8-member ring. If negative charge forms over here 1, 2, 3, 4, 5, sorry, 1, 2, 3, 4, 5, 6 member ring. So again OH minus question mark. So again 6 member ring forms. So 1, 2, 3, 4, 5, 6. So 6, 5, 4, 3, 2, and 1. So at the first position you'll get a OH and there will be H, and at the sixth position you'll get this one. So when you heat it, so you will get this one as the product. So when we took this compound, we got this as a product of 5-member ring, and when we took this compound, we got a 6-member ring as a product. And we took this compound, again a 5-member ring. So when we took this one 6-member, we took this one a 6-member. So it's all about practice. How much so ever you practice organic chemistry, it will be beneficial. Okay. So the next reaction we will see the condensation with nitroalkanes. What is nitroalkane? Basically this R, this I'll take RCH2 O2. This actually coordinate bond exists, so I'll write this as like this. Okay, coordinate bond exists. Okay, actually it exists like RCH2 N double bond O. This is the coordinate bond. So essentially the electrons are given to the oxygen only. Okay, that's why I've written a positive charge on nitrogen. So this is essentially the nitroalkane. When this undergoes the same this attack, this forms RCH minus N plus double bond O minus. Do you understand? Nitro group is a strong electron withdrawing group. You should have read in general organic chemistry. See, whole organic chemistry is based on general organic chemistry. Time and again we repeat the same word, general organic chemistry, GOC. Instead of GOC, we actually when we were studying, we take it GOC as God of chemistry instead of general organic chemistry. So that's how important it is. So due to this NO2 withdrawing group, this negative charge is stabilized, and also due to resonance. See this resonance taking place. Okay. So essentially what will happen when we take a carbonyl compound. When we take a carbonyl compound, for example, pH double bond OH. Okay, this is what benzaldehyde. So this negative charge comes and attacks this one. Okay. Same thing. The mechanism is very, very similar. So CO minus H CH R NO2. Okay. Now again this will with water. It will be pH CHOH CHR NO2. This undergoes heating to form pH CH double bond CrNO2. So this is simple reaction with nitroalkanes, same mechanism. Only thing is that this one has a strong withdrawing group for stabilization of the negative charge. If you take the acetone kind of structure only with carbonyl compound, this CH2 negative is favored by what? Only resonance, right? So, but here the electron withdrawing group of nitro group, nitro group, and also resonance stabilization takes place. So, in fact, this is more stable than this enolate ion. So that's one point I need to remember. And similarly, we take up the condensation with nitriles. Nitriles is what? Essentially, this is RC triple bond N. Okay. So, for example, if you take RCH2 C triple bond N, what will happen again? OH minus will attack. This R CH minus C triple bond. This also is resonance stabilized, guys. See, this resonance stabilization exists like C double bond N minus. This is something. Okay, this resonance stabilized. That is the main important thing. Resonance. So what will happen? Again, if you take some R dash C double bond OH. This is a carbonyl compound plus RCH2 C triple bond N. What will happen? This RCH2 CNL, right? This will undergo this attack RCH minus Cn. This will attack what? R dash C double bond OH. This will go here. So RCO minus HCH CnR. This will undergo this reaction with water. RCH OH CHCnR, and we heat it up. RCH. See, if you write keep on continuously, you'll get a good practice of this. So same thing, condensation with nitroalkanes, condensation with nitriles. So we be happy, guys. We end the chapter of alpha, aldol reactions, set of reactions. From the beginning, we have seen a lot of interesting topics and reactions too. Um, you know, which majorly occupies the carbonyl compounds chapter. So we'll take up more questions now. So this is you can say this is the end of this chapter. Okay, this alpha reactions. Because see, only because of C double bond O group. Okay, the alpha carbon of the C double bond O group. Everywhere the same mechanism takes place, and the mechanism is similar and giving out different products when it reacts with the different things, out of which the haloform reaction, aldol condensation, everything plays a major role in reaction synthesis. When you complete whole organic chemistry and in your 12th class, you can see that the aldol condensation reaction, the product is what, this one, right? Beta hydroxyaldehyde, or a ketone that can synthesize a number of products that you have to read organic chemistry on the whole. So okay, guys, this is the end of the chapter basically. Now we'll take up some questions regarding this chapter.